Hello everyone, today we are going to see about how to interface 7-segment display with PIC16F877A, and also we are going to write a program for the 7-segment display for counting the values from 0 to 9. So let's see the program how it is work. Okay, let's get into the basics of 7-segment display. In 7-segment display we have two types of displays. One is common anode, another one is common cathode. So in common anode, the LEDs all positive pins are connected together and act as a power pin, and other end of the LEDs are act as a data pin. In common cathode, the negative pins of the LEDs are connected together and act as a power pin, and other end of the LEDs are act as a data pin. The 7-segment displays are controlled by ones and zeros. So if it is 1, the LED will get glow. If it is 0, it will get off. So that is in the case of common cathode. The vice versa is happened in common anode. So if we give 0, the LED will get on. If we give 1, the LED will get off. So for that purpose, we have the number system. So we are going to display the 0 to 9 values. So for all the values, we have a binary values here. So these are all the binary values where the LED should get on or off. So for the common cathode, this is the binary value. For a common anode, these are all the binary values. For a microcontroller, we can give any of the values to display. Most of the time we will use hex code to display because it is short. So the equivalent hex code for the binary values are written here. You can use this binary values to display the values from 0 to 9. Okay, let's get into the program. So in our program, I have first included the header file PIC16F877A.inc for the basic purpose. And I have initialized the 3 variables for delay purpose, that is 20, 21, 22 registers, that is file registers. Here is our basic program, or in all our program we will use this instruction. Why? Because we are going to configure the TRIS register whether it is output or input. So in our case the display is an output port, so we are going to make the port C as an output port. So first to configure the TRIS register, as usual we know that we should select the bank 1. For that I am using BSF status RP0 so that it will select the bank 1. So after selecting the bank 1, I am giving the clear F TRIS C so that it will become the output port. Why? Because if we give 1, it will become the input port. If we give 0, it will become output port. So clear F means it is 0, so that I am using the clear F TRIS C. After configuring the TRIS register, we should go back to bank 0, so that I am giving the BCF status RP0. So that's all our initialization. Now we come to our main program. In our main program, we are going to display the values of 7-segment, that is 0 to 9. I already displayed the hex value for the common anode display. So today I am going to use the common anode display. These are all the values I am going to use in the program. Here we are going to use only 3 instructions. One is for loading the value in W register and moving to the port C, and then we call the small delay. That's our process to continue through the 0 to 9. All the same process. First I am giving move LW C0C0H. I am moving the value C0H to the W register. After that move WF port C. This will move the value from the W register to port C. After moving this value, I am going to give a small delay because the microcontroller works in a microsecond. We cannot see the displaying values, so that I am giving called delay. So I am already written the delay program for 1 second. So this delay program I have explained detailed in Blink program. So you can watch the Blink program for detailed explanation of delay. So now I am going back to my program. So after the delay function is over, it will return to the call condition. After that it will display the next value, that is F9H, that is the value 1. So this will be repeatedly done till 0 to 9. After 0 to 9 value is displayed, it will go to the main program. So I have given go to main, so that it will go to this label. So this process will be as a loop till we turn off our microcontroller. It will still counting 0 to 9 as a repeated loop. So that's it. This is a very simple program. Now we can build this program. So building this program. So our program is right, so that it will shows build succeeded. So now we can simulate our program in Proteus so that we can see the output, it is working or not. So go to Proteus software, take PIC Microcontroller and then 7-segment common anode display and give a power and connect to this port C. I have given in port C so that you can use the port C. In any other port you can use. So I am loading the program here. So by double clicking here, you will redirect to the hex value where in which folder you created. This is the 7-segment hex value. So by double clicking it, it will load. Click OK. Press the play button. You can see the 0 to 9 count is begins. So that's all our program. The basic 7-segment interface is over. Next video I will explain you how to interface the multiplexing the 7-segment display and other application based on 7-segment display in future videos. Thank you for watching.